This is GCSE Forces lesson 16, and this one's movement and position. And the objective is to understand what information we can obtain from a distance time graph. So the slope or gradient of a distance time graph gives you the speed. So a quick example. So I'm just going to compare two lines. So this one might be slower than, for example, this one. So the faster one has the steeper gradient, therefore it has the greatest speed, or it's faster than the red line. So the slope or gradient of a distance time graph gives you the speed. If you want to make a note on that, just pause, and then I'm going to go through an example of how we actually calculate a value. So here's another distance time graph, and as you can see, we've just got a straight line, and the gradient or the slope will give us the speed. So to do that, what we need to do is take the gradient, and I'm going to show you how to do that. So if we start from there, dash line. You can do solid lines if you want, but I normally do dash for these types of things. So the gradient is given by the change in y. So the change in y divided by the change in x. Now, obviously, as a scientist, a physicist, I don't want to write that every time. So the change in y we can actually write like this. So it's change in y divided by the change in x. Now that triangle looking thing, if you're not sure what that is, it's not a triangle. Well, it looks like a triangle, but it's actually a Greek letter. It's delta, capital letter, delta. And it simply means change. So the change in y, we look at how much y has changed. So it starts at 0 at the bottom, and then it goes up to 6,000 at the top. So the change y has changed by 6,000, and it's meters because it's measured in meters. So I'm going to write 6,000 meters divided by the change in x. So it goes from 0 to 240 seconds. So if we do 6,000 divided by 240, as you can see, it'll give us a unit meters per second. So you just need to put that in your calculator. So 6,000 divided by 240 will give you 25 meters per second. Hopefully that makes sense. Now I'm going to give you a different question that you can have a go at. So a similar graph. Just be careful with this one. I just want you to find the speed of this, whatever it may be. Okay, so remember, to get the speed of a distance time graph, we do the change in y divided by the change in x. Now the change in y, so we start at this 0 point, we go up to here. Now that is, well, let's have a look. So that's 120 and that's 160. So this middle bit will be 140, and this seems to be in the middle. So where it reaches is about 150 meters. So the change in y goes from 0 to 150, so it's 150, divided by the change in x. So the change in x is between 0 and 10 seconds. So 150 divided by 10. So that gives the speed, so it's meters per second. So 150 divided by 10 is 15 meters per second. Hopefully you got that one. All right, let's move on. So what I want you to do now is to sketch this. So do a distance time graph, just a sketch. And I want you to we're going to label 3 things on it. So the first thing I want you to do is a car moving at a steady speed. So you might want to pause and then unpause when you're ready to move on. So I'm going to put the answer on now. So it might look something like this. Okay. Now for comparison, I want you to do a bus moving at a steady speed that is greater than the car. I'm going to put the answer on now. So that line would be, it's a steeper gradient, so it's definitely moving faster than the car. Now the next one, I want you to do a lorry increasing in speed from rest. So what might that one look like? I'm going to pause and have a think. I'm going to put the answer on now. So as you can see, the gradient's increasing because it's increasing in speed. So obviously the steeper the gradient, the faster it's going. So starts off low gradient and then gets steeper and steeper to show that it's actually getting faster or accelerating. Okay, let's move on. Hopefully that one went okay. So you can have a look at this one if you want to pause and have a go. So describe the motion of the three lorries X, Y, and Z as shown in the graph below. So just as a description, lorry X is just traveling at a constant speed because it's a constant gradient. It's moving the fastest. Lorry Y is also moving at a constant speed for the entire duration from 0 to 1800 seconds. Now lorry Z is traveling at a constant speed from 0 to 600 seconds. Then it's a flat line between 600 and 1200 seconds. Now a flat line means that no extra distance is being covered, so that means that the lorry is actually stationary. Then the lorry starts driving again from 1200 to 1800 seconds, again at a steady speed because of the steady gradient. Now what you can do, if you want, is to calculate the speed of X, the speed of Y. So let's write these down. So I'll just put, so speed of, let's do X. Then you can do the speed of Y, just as a bit of practice. And then Z, there's going to actually be multiple calculations you can make. You can calculate the speed of Z in this first region, if you wish. So that'd be one sum. The speed in this region we already know is 0, so you don't need to do that. And then an extra calculation, you can calculate the speed of Z in this region. So there's 2 to do there. You've got number 1 here, number 2 there. Then you can also do the average speed of Z. So the average speed of Z will be looking at the entire thing. So from that point A to point B. So you can have a go at that now if you want. I'm going to put a tip on for that if you want to calculate that. So if you want to get the average speed of Z, you will need to do the full gradient. Okay? And if you need some more help, Y is approximately 36, maxes out at 36,000 meters. So if you want to have a go at that now, and then I'll take you through some answers. Okay, let's have a look then. So lorry X, so it's moving the quickest as we discussed. So the change in Y divided by the change in X is 45,000 meters divided by 1,800 seconds. So you should have got 25 meters per second. The next one, lorry Y. So 36,000 meters divided by 1,800 seconds gives us 20 meters per second. Lorry Z, so it's moving the slowest. The first region is 10,000 meters divided by 600 seconds, which gives you 16.7 meters per second. 600 to 1200, as we discussed, is stationary. And then once again, 1200 to 1800 seconds is the same gradient as the initial one. So that gives a speed of 16.7 meters per second again. Now the average is the total distance divided by the total time. So that'd be 20,000 meters divided by 1,800 seconds, which gives an average speed of 11.1 meters per second. Hopefully that all went okay. Let's finish with this closed exercise. So if you want to have a go at that now, with the keywords. So if you want to pause, and then I'll take you through the answers. And I'll do that now. So speed is equal to a distance divided by time and can be measured in meters per second. A speed of 20 meters per second is the same as 72 kilometers per hour. So you should have been able to calculate that, which is approximately equal to, you might have Googled this one or just used some common sense as it being the only number remaining, 40 miles per hour. If you ever want to convert between kilometers per hour to miles per hour, sorry, you would do 72 divided by the number of kilometers in a mile, which is 1.6. So I'll just write that. Just out of interest, 1 mile is 1.6 kilometers. Let's move on. The something, so the slope or the gradient of a distance against time graph can be used to calculate speed. The greater the gradient of the line, the higher is the speed. The line will be horizontal when the speed is 0. So I hope you found that useful. Thanks for watching, and I'll speak to you soon.